What's up, guys? Today you will learn something new. But first, I will introduce my group mates: Joey Carillo, Chindi Pudunas, James Kolar, Sheila Grace Pulungasa, and yours truly, Rafi Sibayan. And now Joey Carillo will introduce to you our activity.
Did you know that we are all surrounded by data and we use it in our daily activities? Whichever school you studied, whatever is your job or whatever is your interest, you will almost certainly have came across a story about how data is changing the face of our world. In fact, data is the basic unit in statistical studies. In order to analyze data, we need statistical tool. And one of these statistical tool for analyzing research data is called Minitab. Minitab is an ideal package for learning statistics. It provides a simple, effective way to input statistical data, manipulate the data, identify trends and patterns, and then extrapolate answer to the current issues. Minitab also provide many statistical analysis such as regression, normal distribution, and ANOVA. In this video, we will show you how to use Minitab and its basic command tools, and also demonstrate on how to solve a normal distribution and ANOVA using Minitab. Hello guys! We will teach you how to use Minitab. But before that, I will introduce to you the basic command of Minitab. But first and foremost, you need to open your software. And the first thing that will pop up in your screen is what we call the data window. And on the upper portion of your window, you can see the basic command of Minitab. Well, I'm pretty sure that you are all familiar with this since it's look like just the other software like a Microsoft Word, which is very common. So it will be just an overview. The first one is the file. This is where you can save your worksheet or import your data. Or if you want to, you can create your new file by just clicking this new. The second one is the edit. As you all know, this command is created to allow you to cut and paste text and data across window. And the third one here is the data. This command allows you to control your input data in your worksheet. You can combine multiple worksheets or vice versa. Anything you wanted. The next one is calc. I think this is a short term for calculation. Since when you click here, you can see a calculator, column statistic, row statistics, which is all involved in calculation. The next one is stat. You can see here a basic statistic regression, ANOVA, and DO, and so many more. This command is a lot useful than you think, no? Because why? Well, you need this command to analyze data, which is why what is your main goal. That was your main goal while using Minitab. The next one is graph. It is a graphical representation of your data, which is obviously useful to identify the relationship of your data, if it is inversely proportional or directly proportional or whatsoever. And you have many choices here. You have scatter plot, matrix plot, bubble plot, and you ever have a histogram and a box plot and a chart. And this remaining command is very common, and I know you already know this, so let's just proceed to our exercises. We have one problem for normal distribution and one problem for ANOVA. On these exercises, I'm pretty sure that you will be able to practice the basic command and appreciate the existence of Minitab. So the exercises that we have here will be explained by my groupmates, so just hang in there.
So what's up, guys? For today's video, we're gonna teach you how to solve normal distribution using statistical app that we called Minitab. So today we're gonna solve a problem, and here's the problem. Let x, the duration of an 8-week-old baby smile, where X is normally distributed with mean is equals to 9.1 seconds and standard deviation equals to 2.2 seconds. What is the probability that a randomly chosen 8-week-old baby smiles between 6 and 12 seconds? One of the best way to show your complete analysis about the data is by using graphs and illustrations. So let's go to the menu and click the graphs, and let's use the probability distribution plot. When you create a probability distribution plot, you specify one or more distribution and parameters so that you can visualize and compare distributions. You can also shade the area under the distribution curve to represent a value that you want to specify. Using probability distribution plot is perfect for illustrating normal distribution. So after clicking probability distribution plot, let's click this view probability. Then okay. After choosing probability distribution plot, let's choose view probability because it shows X values and probabilities in a shaded area. For example, this plot shows an X value for specified probability. And for the distribution, let's click normal. So let's click normal. There it is. Why? Because we're solving normal distribution. And in the mean and standard deviation, let's input the given values in the problem. Where mean is equals to 9.1 and the standard deviation is equals to 2.2.
Hi guys! We will continue the remaining step in solving normal distribution. So let's start. Click the shaded area. Under the shaded area, click the X value. We let X represent the duration of an 8-week-old baby smile. And now, click middle. Since we want the proportion of 8-week-old baby with a smile duration between two values. In X value 1, type 6. And in X value 2, type 12. So the X and the 12 are the interval in this problem. Then click OK. So this is the distribution plot that we got. The 0.8269 is the probability that we got using Minitab. While earlier, we got 0.728 probability that computed by hand. As you observe, there is a difference by point that may just be neglected. Therefore, the answer that we got is correct. And there is the probability that a random chosen 8-week-old baby smile between 6 and 12 seconds is 0.8269. So that's it. James and Shindy will continue the remaining problem about ANOVA.
So, hello everyone! So, the next problem that we are going to analyze is an ANOVA exercise. So, the problem goes like this. An engineer wants to compare the hardness of 4 blends of paint. 6 samples of each paint blend were applied to a piece of metal. The pieces of metal were cured. Then each sample was measured for hardness. In order to test the equality of means and to assess the difference between pair of means, the analysis uses one-way ANOVA with multiple comparison. So the first step that we are going to do is to open the sample data. Click File on the menu and click Open, or you can press Ctrl+O. Then select the file provided. Then click Open. So here's the data in the worksheet, as we can see. So the next step that we're going to do is to click the Stat or Statistics. Then select ANOVA, one-way analysis of variance. Then choose response data and one column for all factor levels. So for the main solution of answering this problem will be explained by James. See you!
Thank you, Chindi. So, after you select the response are in one column for all factor levels, enter hardness for the response. And for the factor, enter paint. So, click the comparisons tab here. Then, click Tuki. Then, check OK. Tuki. Then, click OK. Then, click OK. Then, there you have it. The one-way ANOVA. The analysis of one-way ANOVA, hardness versus paint. So, from our data, here, the independent variable is the 4 kinds of paint blends, and the dependent variable is the hardness of the piece of metal for every blend sample. As you can see, we are comparing 4 groups of paint blends, and each group of paint blend has 6 blends. Here, 6 blends each. So, here, for blend 1, we have an average of 14.73. For blend 2, we have 8.57. For blend 3, we have 12.98. And for blend 4, we have 18.07. Here, blend 4 express the highest level of average for metal piece hardness. Going to the standard deviation, here, or the average amount of variation in scores with subsample, as you have observed, blend 2 has the highest amount of variation in scores within its blend group. Blend 2 is here, 5.50. And blend 4 has the lowest amount of variation in scores within its group. Blend 4, here. So, the other table, the table for analysis of variance, we need you to focus on here, table here. Is in the F score or F statistics. For this time, we have 6.02, which means we have to reject the null hypothesis because it is greater than the F ratio. And then the significance level, which means the probability level. The higher the F value gets, the lower. So in this case, we have 0.004. So we can say that it is statistically significant. So for here. For the two keys simultaneous 95% CIs or the confidence intervals or simply differences of means for hardness. As you can observe, blend 2 minus blend 4 minus blend 2 has the highest difference because as what I have said a moment ago, the mean of blend 4 has 18.07, the highest, and for the blend 2 it has 8.57, the lowest. So it means they have the biggest or the highest difference for means for hardness. So in the next graph, we have the interval plot of hardness versus paint. So as you can see, blend 2 has the lowest and the blend 4 has the highest. So it means in terms of hardness, blend 4 has the highest mean. So I think that's all, and I hope you got more knowledge, and thank you.
Thank you for watching. I hope that you learned something from our video. Don't forget to hit the like button, share, and subscribe to our YouTube channel. Thank you. Bye bye.